My name is Drew Bradstock. I wanted to welcome you to our session talking about how GKE and Cloud Run can help accelerate application development. So I am in charge of product for both serverless and Kubernetes. Joining me today is Steren, who leads product for serverless. And we also have the pleasure of Brian and Corey joining us from Etsy, where they're going to tell the real story versus the Google story of what their experiences are with containers. Now, it's really hard to believe that it's been over 20 years since Google created Borg and our own container management system. We've made huge strides during that time period. Let me go ahead. Hold on 1 second. We've made huge strides during this time period, and Kubernetes itself is over 10 years old at this point. It's hard to imagine what people did with containers before that point outside of Google. During this time period, we've looked at automation, we've looked at efficiency, we've looked at security, such that all of you don't have to take care of that. That led us to actually add autopilot mode, where much of the work is done by Google for you, still with the flexibility of the Kubernetes ecosystem. And even before that, we actually pioneered with Cloud Run, which is the easiest serverless offering in the market, which Steren will be speaking about later today as well. Now, one of the things that we're actually most proud of is the fact that you have choice. You're not locked into either Kubernetes or one serverless product. We have the options of Cloud Run, which gives you the ability to get going with containers incredibly quickly. Now, containers, for many people moving from legacy VMs or older on-prem systems where your build systems may be a little legacy or long in the tooth, can be really challenging. This is where we found customers have accelerated that journey with Cloud Run because it's opinionated with locking you into a traditional pass and allows you to get going quickly. Additionally, you can scale up to handle any workload possible. And one of the cool things we'll walk through is how easy it is to actually move your containers from Cloud Run to GKE or from GKE to Cloud Run. Now, on the flip side, if you don't want, or if you do want to use Kubernetes, GKE is a great option for you. So Cloud Run is a really fast way to get going in containers all up, and we're seeing more and more customers actually stay with us and grow large-scale deployments like IKEA and others. But for GKE, our focus has been, one, make sure that we actually practice what we preach in terms of our investment in open source. For instance, in the last 60 days, we've made more contributions to Kubernetes than many of the leading cloud vendors have in the history of Kubernetes. And this is really where chopping wood and carrying water and doing the hard work and enhancing the products based on feedback from many of you make a fundamental difference in terms of our implementation just being easier. Beyond that, if you look, we've actually really heavily optimized for new AI workloads. AI, as you may have heard maybe 1 to 50, 100 times, and that is a number this morning, has really changed the game, but Kubernetes is a really good fit for this. But once again, one of the struggles we've seen is that people don't want a Swiss Army knife of options. They want to be able to grow to any size, but they do want opinionation such you can get going with GPUs or TPUs or any of the leading AI frameworks very quickly. And that's what we're investing in Kubernetes right now. And lastly is auto-scaling, HA, and security. These are all things you don't want to have to build yourself and worry about, so we made it easy to do so. Now, one of the coolest things for Cloud Run is actually how easy it is to get a container going from having that container to live in production, fully serving traffic. So we've got a nice little demo, and thankfully to Steren and our crappy Wi-Fi across Moscone, so apologies for that, we've got this pre-set up. But Cloud Run takes care of all that heavy lifting for you. It's very, very good with handling your traffic splitting, getting it fully deployed, and in literally seconds you're live with either your new iteration or a brand new container. And this has led to a lot of companies from the smallest startups all the way to the largest enterprise and digital natives embracing Cloud Run because of the speed to deploy and how well it ties into all our development tools as well as the ecosystem. Now, Cloud Run does have two major strengths. One is traditional services you may think about, where it's the way you'd really use Cloud Run. But Cloud Run Jobs opens up a huge realm of batch opportunities too, because of that great nature of 0 to 1,000 and 1,000 to 0 and back down. So I encourage you to check it out more and obviously listen to Steren in a few minutes. Now, near and dear to my heart, I've worked on GKE and Kubernetes for many years now. GKE Standard is the product that many in this audience use right now. One of the cool things about it is the level of automation and security we've brought into it to make it a lot simpler to actually get your cluster going without having to do the work that you may have to do in other clouds with this system. Additionally, we have looked, as I mentioned, looking at GPUs and TPUs such you can run any AI workloads you want, and you can play the home game of counting how many times we mention AI today. But it is all about simplicity. Every single point of friction makes your life more difficult. So our job is to remove the difficult bits from Kubernetes, and that's where we're constantly looking for feedback from all of you. And lastly, as I mentioned, is how do we have a secure, really good single cluster environment here? Now, one of the problems that you still have, though, is what happens if you have more than one cluster? So quick show of hands. How many of you have one or more Kubernetes clusters? OK, how many of you have 10 or more? It's exercise. It's 4 o'clock. Quick show of hands. Keep those hands up. How many of you have 10 or more? OK, how many of you have 50 or more? OK, how many of you have 100 or more? 1,000 or more? I was going to say, I know who's at a certain level for all our clients, but it's easy to manage one. It becomes really hard, just like any fleets. Like when we had VMs first come out, it becomes harder and harder to manage more and more. This is also compounded by the complexity of Kubernetes and adding all the add-ons. So what I'm really excited to actually announce, TK stole a little bit of my thunder this morning, but he's allowed, that's his job, is GKE Enterprise Edition. This actually builds on top of GKE Standard. Still, all the functionality you have in the GKE Standard right now remains with Standard Edition. No changes whatsoever. But what we've done is we've built multi-team, multi-cluster management such you can take a look at your fleets, build in observability, build in security, build in compliance, build in config, all across many clusters at once, be it a one-cluster fleet or literally in the thousands with some of the customers that we're testing right now. Additionally, you have security and governance and new functionality there, looking for vulnerabilities that's all being built to look at one cluster or many. And all part of this is actually all the functionality we have within Anthos is now included as part of GKE Enterprise Edition. So any of you using Anthos for multi-cloud, hybrid, or even on GCP, all that functionality does not go away, but is now within one unified console and experience within GKE. What I'd like to do is actually welcome up the Etsy folks to walk through their experience working with Cloud Run and a little bit of what they've seen within GKE. So gentlemen, I'll leave you to introduce yourself.
My name's Corey Samuels. I'm the engineering manager for Etsy Service Platform. We affectionately call the service platform ESP, so you'll hear that referred to in the presentation today. I'm here with our tech lead, Brian Akins, and we're really excited to share a little bit about our journey to design and build a service platform for Etsy. We're going to walk you through the what, why, and how of our platform, and then we're going to dig into what we built and some of the challenges and successes that we encountered along the way. So let's start first by answering the question, why did Etsy need a service platform? So prior to moving to the cloud in 2019, Etsy was primarily powered by a PHP monolith that was in a data center. And because it was in the data center, we were constrained both technically and hardware-wise as to what we were able to build. As the company grew, the need for services grew as well. And moving to the cloud enabled our engineers to take advantage of new service platforms where they could put new services outside of this core monolith, which still powers much of Etsy's marketplace today. This evolution to services occurred organically, but very quickly we saw that some problems were emerging. We saw that teams were duplicating infrastructure and scaffolding. Service attribution was unclear, sometimes ambiguous. We had no central service catalog, so services weren't easily visible or even accessible. And finally, we had gaps in standards, operational process, and support of services. So to address these problems, we assembled a squad of architects who spoke to many teams around Etsy who were writing services. And ultimately, the squad created this vision document, which would serve as the blueprint for how service development what service development would look like in the future. The core principle of this vision was to decouple service writing from the infrastructure that the services ran on. This solved two problems for us. First, it freed service writers from the burden of infrastructure. And secondly, it provided us a path to introduce standards and guardrails into the service architecture.
Thanks, Drew and Corey. Hi, I'm Brian Akins, but most everyone calls me Bakins. It's like bacon, but plural. I'm a senior staff engineer, and I've been at Etsy since May of 2022. When I first started at Etsy, this vision doc that Corey mentioned had already been completed, and then the service platform team that I joined was tasked with taking that vision and making a practical working service platform from that vision document. After my initial onboarding, we discussed what would be the success criteria for a service platform. We ask ourselves, how can we best spend our time? And we ask ourselves often, like in a year, if we look back, what would be a successful service platform? We kind of came to the very obvious conclusion that a successful service platform would enhance the developer experience to make their lives easier. Seems obvious, right? But we needed to dig a little bit deeper, like how would we know when we were successful? You know, like how would we know when we've reached that? But then what are the actual steps that we need to get there? So to do that very quickly, we conducted interviews and did small proof of concepts with teams around Etsy engineering, including some of the more operational focused teams, because we wanted to get that perspective as well. Because we want to know what were the day-to-day pains in both writing services as well as supporting those services once they were in production. And we wanted, like, how could we create a platform that would allow those writing services to focus on their business logic while providing the operational foundation that all production services need, so that it would also make the lives of operators easy as well. And then finally, how would this align with this kind of architectural vision that came from a little bit from the committee there? It became clear from talking with people that we had two basic use cases which are like, hey, I have a great idea. How can I quickly get that in front of customers by integrating it into the Etsy product? And that idea was successful. How do I support that long term? We often say on the service platform that an engineer's time and attention are the most valuable assets that we have at Etsy. So we wanted to make sure that we made good use of our engineers' time. So we wanted to be able to quickly iterate on the value that we thought that the service platform could provide, and knowing that the entire engineering organization was our kind of, potential marketplace for this platform. And to do that, we wanted to focus on the Etsy-specific parts of a service platform. We weren't looking to build a generic service platform for all of the world to use, but for Etsy, for our engineering organization to use. And me being fairly new to the team, I had to rely, like I say, on a lot of these interviews and talking with people and doing that. Etsy's a very kind of face-to-face, one-on-one type company, so establishing those relationships across engineering was very important for us, to get in there and hear their story, like what was it like when you launched something, how did that go, what do you wish had gone differently about that. So to do that, we knew from the beginning that we needed to use the highest level service by Google or other providers that would allow us to focus on that Etsy-specific part of the service platform. We didn't really have the time nor the people, we're a fairly small team, to make a whole lot of upfront infrastructure decisions and implementations before we actually dove into the actual work of building the service platform. While we're big fans of offerings like GKE, which we've mentioned already, by using a platform like Cloud Run, there were just entire classes of problems and decisions that we just didn't have to make. Whether we liked that opinion or not, it was just something that we could start with. And sometimes just deciding takes a lot longer than the actual doing. So we got to start off much quicker. Abstraction layers are obviously hard, but we wanted to do our best to make sure that we didn't expose too many low-level details to our service developers so that they could focus on writing and supporting their business logic.
So we generally don't have a strong culture of technology mandates, specifically in terms of platforms at Etsy. So it was very important for us to take that into account when we were figuring out our strategy of how we were going to design and build this platform. We could build something that we thought was perfect, but if our engineers, who were going to be our future customers, weren't sold on the platform, adoption would just be difficult and the project could fail. So our approach around this was to first assemble a team of engineers who had skills both in infrastructure and application development. After that, we put 3 things in place. First, to make sure that we stayed aligned to that architectural vision that we were given, we composed a small sort of advisory group that included 2 of the original architects who had authored the vision. And we met with them weekly to discuss implementation and design details of the platform. Second, to ensure that we stayed true to what our customers actually needed, we partnered with one of our teams, our ads team, because they were already writing services and they were a perfect fit for what we were planning to do. So one of their engineers actually rotated into our team and helped us build an MVP, build and design the MVP. And then our pilot service was one of this team's services that they were planning to build outside of the platform. So that aligned really, really well. Lastly, we adopted a very flexible and adaptable roadmap strategy. So our team's work on platform features and support would align with what our customers actually needed, our service writing teams. So our MVP was launched at the end of last year, and then we followed that soon after with the launch of our ads team pilot in Q1 of this year. So now that we've given you some historical and sort of strategic context of our service platform, let's take a look at what we actually built. So ESP at its core, it's a group of components that we've glued together into a cohesive service development experience. For our developer interface, we chose to write a custom command line tool, and that integrates really, really nicely with our CI/CD workflow, which is powered by GitHub Actions. For communication, we standardized on gRPC, and we use protobuf for the serialization format. Etsy engineers use a pretty broad number of languages, and to help get adoption going, we wanted to support as many as we were able to. So on the service side, we support Go, Node, and Python. And then on the client side, we support languages that are needed around Etsy ecosystems, like PHP, Java, Scala, Python, and Node. So those clients are automatically packaged up, versioned, and then registered at Artifactory. And then all of the services are cataloged into our service catalog using Backstage. Finally, Google services played a critical role in these components of our platform. All of our observability tooling is powered by Google Cloud Services. And most importantly, all of our services are running on Cloud Run.
Before the launch of ESP of the service platform, each of these boxes you see, and actually the links between each one, was a decision that a development team had to make the decision and actually go and implement that technology to support that. And often they would do this for each service that they supported. And since teams are often fluid, as you know, this led to like many, many different ways to deploy services without much standardization, as Corey had said earlier. So we wanted to avoid a one-size-fits-all approach. However, we did know there were key features that we needed to enable the general life cycle of the services and to support the developer workflows. And since we didn't want to use the build it and they will come mentality, because they never come when you build it, we used our pilot service and our partner team and the ads team to drive the priorities and requirements for at least initial phase of the MVP. We wanted to make sure that we were actually building something that our users would actually use. As Corey said, we wrote this command line tool called ESP. That's the primary way in which developers interact with the platform. It's really a wrapper on top of other tools, as you can probably imagine. And it's just there to provide a consistent kind of CLI interface rather than having to know, 10 different tools and everything. And it provides common tasks for like creating new services as well as working with services that are already written. It does things like it handles your proto generation, so where you generate your code from proto C files. And it also handles like running the service inside of a container locally like you would do it in Cloud Run so that you can have a similar experience. But it also is used to run unit tests locally and those types of things. It also generates language-specific container build, so developers never really have to deal with Docker files. And so we're able to bake those best practices in there. Particularly, we're working with like our application security team to make sure that we get updates injected into the platform without having to go touch, 10 different repos. The service platform also provides a small framework for each supported service language. We call this the runner because or at least I am very terrible at naming things. We utilize code generation a whole lot, sometimes for better or worse. But what this framework does is enables developers to be able to focus on just writing like their service methods without having to worry about things like setting up observability, like setting up a gRPC server, figuring out what port to listen on, like very mundane things, but these are things that if you've never written a service, if you're starting from scratch, that you have to do. There's a good bit of ceremony involved. It also provides just a base level of observability out of the box. So you get pretty good, like metrics logging, tracing, and those types of things without doing anything, within your service beyond writing your business logic. And one of the things is we wanted to do this so that a service developer can focus on writing the code, implementing that idea like we were talking about earlier, but having best practices for operational and infrastructure baked into the platform so that we provide pretty good guardrails for most use cases just out of the box. We use this same command line tool in our CI/CD pipeline. So the same tool that you're running tests locally, that's what's running tests in CI/CD for you. That way we just have some consistency between the two. Hopefully this gets rid of those cases where like you've always had that flaky test in CI, but it works fine locally. So that's one of the things that we try to address. I'm not going to say we were 100% successful because you never are. But it also handles other things like actually building the container, as we were talking about generating Docker images, but also actually pushing that to a container registry, deploying it to Cloud Run, and it automatically handles like the promotion from development to production environments, for example. We also generate what we call batteries included clients for each one of our supported client languages. So a consumer is generally working with our generated clients and not like the kind of raw generated gRPC clients, if you've ever used those. But we also, and we say it's batteries included because we include such things as service discovery. So like if I'm working in a development environment on service A and I need to call service B, it automatically knows how to contact the development version of service B without me having to tell it. It also provides instrumentation, so I automatically get all the good, timings and logging, exception handling, and that kind of thing out of the box. So as a consumer, I don't need to put that in there. It also handles environment-aware authentication. So once again, if I'm in development, it knows that I should use my development credentials, and if I'm in production, to use those production credentials, and if I'm on my development VM, which is kind of the way that Etsy does a lot of our development work, it knows then to use that set of credentials. We use Cloud Run native features for authentication and authorization. So that was another case where like using Cloud Run, we just didn't have to worry about that implementation or that decision. And it was just an easy button for our AppSec team to just look at. It's like, oh, you're using IAM, we're good. All services that are running on the service platform are automatically registered in our service catalog. What that does is obviously gives us a catalog, hence the name, but it also does some interesting things, like we get some base level documentation, like you get links to the runbooks for the service, who owns this, what's the on-call schedule, what are the links to the dashboards. But we also do things like we auto-generate like a nice version of API documentation from the protobuf files. And so you can kind of think of the service catalog page for a service as kind of at least an initial hub for a service, so that I, as a consumer, can go look at that, or if I just need to know more information, I can at least go there and it links out to other things. We also use that same service catalog to where integrating that with other services that are not necessarily in the service platform, so that that can kind of be the stop place. Because as you all know, if you don't have at least 6 documentation repositories, what are you even doing? All the Etsy systems, like over here, they use these generated clients to call out to services. So all those great things I said about the batteries included there, that's what they do. For example, if I'm working in PHP and the Etsy web monolith, which is what we call the main Etsy product, like I just work with like high-level PHP objects and don't really have to worry about the implementation details. I might even know there's a such thing as a service platform, and I definitely don't even have to worry about knowing that there's a thing called Cloud Run. Just so that you don't think that we're going to get up here and say all positive things about Cloud Run and Google Cloud, I wanted to at least give you a couple of challenges that we had to work through. And some of these are just obvious in hindsight, as things like this always are, but we wanted to highlight them. Shortly after we launched this ads service, we overloaded a VPC connector. For those who don't know, within serverless, to contact with other parts of the Google infrastructure, particularly those things like a Kubernetes cluster or services that run there, you go through this thing called a VPC connector, which Steren is going to completely hate my description of this, I'm sure. But basically, it's like a proxy server. That's a really bad description of it. But it runs on VMs and everything. And we just completely destroyed ours because we had done a huge amount of load testing, and everything looked fine. But it turned out when we actually turned on this feature in the Etsy website, that user interaction, like actual users, like people sitting at their computers and buying and selling things, was completely unlike what we had modeled before, as users always are. So we wound up going down different paths that hit much heavier endpoints. And so we had to quickly, kind of on the fly, go and make some dedicated VPC connectors just for these services. Services that we launched after our pilot service, just because we kind of knew the pilot service, inside and out by that point. They were a little trickier for us to determine what was the best mix of like CPU and memory allocation versus user traffic versus concurrency, particularly with all the languages that we had involved. And since in Cloud Run you're running in kind of a container and you can't really get a shell, you can't really use like the traditional like operating system tools that we're used to using like on a virtual machine. So that's where we like heavily instrumented all of our applications. And we worked with the development teams to do this because they were the experts at their applications and everything. And then we took things that made sense and we actually ported those back into the platform so that everyone would have access to those. It's like everything in the service platform, as I said, we use Google IAM, so everything is TLS and uses layer 7 authentication. We don't rely on a lot of like private networks or anything there, but not everything in Etsy does that. A lot of older systems at Etsy, which are the money makers, were lifted and shifted from the data center, as Corey said. So we've actually been working with the Google serverless networking team to determine what's the best way to get a performant but secure like connectivity from service to service as well as service to infrastructure without exposing a lot of like low-level details to developers. In our ideal use case, and this is still ongoing, we want them to just state, I need this kind of connectivity and this kind of security, and we figure that out in the service platform. Another instance that we had, which like all the Google services really helped us get started very quickly, like particularly the observability tools, because they're just kind of baked in with Cloud Run and they just work out of the box. You just automatically get a ton of metrics, logs, and traces. However, whenever one of our engineers gets paged at like 2 a.m., as you inevitably do or whatever, they're used to working with like Grafana. And if they're doing ad hoc things, like we're using PromQL for things. So we actually did a little bit of kind of glue work with Google Managed Prometheus and Alert Manager so that we could actually expose all those metrics, both the kind of like Cloud Run native ones that come out of the box, as well as all the custom metrics that we're doing, that we could expose those into familiar interfaces to our service developers. Another thing is whenever we first started using Cloud Run, sidecar support was, I think it was maybe alpha or even like private preview only. And so we were not comfortable necessarily using that. And we use OpenTelemetry for all of our telemetry, logging, observability, and everything. And in general, the way that you do that is run a little agent beside your code. But if you can't run a sidecar, you wind up accidentally inventing an init system, which is what we did. And another thing that we do is we also run a proxy, which is named the entry point, because remember what I said about me and naming things. But what it does is give us a common place for functionality regardless of the language that we're using. So one thing that we're able to do in the entry point, for example, is we actually can do transcoding from like JSON to gRPC so that we can expose things to like more web-based endpoints. That's also another thing that we needed to launch. So we actually wound up making this kind of monstrosity that made sure that all these processes were launched and injected these additional binaries into the server containers as we were working. Since that time, thankfully, Cloud Run sidecar support is much better, and we've been working with that. Okay, whenever we first began working with a service platform, we focused more on the day two, which is kind of the care and feeding of existing services. Because we already had a very engaged development team and our ads team, and we already had a pilot service picked out. So we really didn't need to spin up that many services. But since then, we've actually done a whole lot of work to work on that day one thing, like I have an idea and I want to test it with Etsy. And so we built a sandbox environment and kind of like a pared down version of the platform, if you will. So I can go from absolutely nothing, type ESP init, which is how you create a new service, and have a shareable link to something deployed in GCP in about 5 minutes or so. So not too bad. And that includes CI/CD and observability as well. Most things have just generally worked. For example, after we launched the ads pilot and we got over our VPC issues, they more than quadrupled the amount of traffic going to this service by using it in more places around Etsy, which was great. And we didn't even really notice. Like Cloud Run auto-scaling just worked. I'm not going to say it's always going to do that, but in this particular use case, it worked really well for us. We have some requests for things that do not nicely fit into the serverless model. And so we're actually working with Google and our internal GKE teams to actually extend the service platform to work on more traditional GKE platforms as well. Because we want to provide the same consistent developer experience regardless of the runtime. And speaking of that, Steren's going to talk to us a little bit about how you can use GKE and Cloud Run together.
Thanks, Brian. That's right. I'm going to tell you how Etsy and all of you can use both Cloud Run and GKE together. So first, let's recap. You heard it from Drew. What's Cloud Run? Allows you to deploy and scale containerized apps in a fully managed environment. So it's simple, it's automated, and there's no cluster management to worry about. Google does that for you. And yes, Brian, we heard you, VPC connectivity could be better. So that's why we've launched a few weeks ago direct VPC. No more serverless VPC connectors in the middle. Your Cloud Run services can just directly send traffic to your VPC network. Simple. And we've also launched recently sidecars support for Cloud Run. So notably, with sidecars, that can help you bring an observability sidecar like OpenTelemetry or Google Managed Prometheus. Check out those two new features of Cloud Run. I'm a big fan of them. So now, Cloud Run and GKE. Many customers have moved workloads between Cloud Run and GKE from and to. And actually, we've designed Cloud Run to avoid lock-in and to enable portability. We've designed it that way from the beginning. So obviously, the portability is enabled by Cloud Run and GKE supporting the same software deployment artifact, the OCI container image. The same image can run on GKE, on Cloud Run, on your local machine, anywhere containers are running. There is nothing proprietary about Cloud Run in a container that you deploy to Cloud Run. But we didn't stop here. Cloud Run goes further than that. Cloud Run is not using Kubernetes under the hood, but its V1 API is designed to enable portability with Kubernetes. And so the Cloud Run API actually share the same structures and attributes as Kubernetes. So in this simple example, you can see the similarities between a Kubernetes deployment and a Cloud Run service. As you see, most fields look exactly the same. And the diff is just a few lines. So now I'm going to tell you about how you can use both together in 3 ways. How you can manage them together, how you can secure them together, and how you can bring them together in the same data path. So on the consistent management side, first, there is a product that is called Cloud Deploy. Cloud Deploy will allow you to do continuous deployment to both Cloud Run and GKE, managing environments and parallel deployments, canary deployments. Cloud Deploy does all that. Next, if that's your thing, you can manage Cloud Run services using kube control. To do that, you would need to leverage something called config connector, but you can use kube control to manage Cloud Run if that's what you want to. Then when it comes to built-in observability, those two runtimes have built-in support for logs into Cloud Logging. You can browse your logs from Cloud Run and GKE in the same place. You can observe the metrics from Cloud Run or GKE in the same cloud monitoring dashboards. And you can even define service level objectives, SLOs, on your Cloud Run services or your GKE services and see them in a centralized location with SLO monitoring. And finally, you can, as we mentioned, enforce policies or collect telemetry using the exact same sidecars on Cloud Run and on GKE. So that's about management. What about security? Yes, sorry. So both Cloud Run and GKE have the notion of workload identity. A workload identity is basically an identity you give to your services and that determines what it is able to do. And you can use that for the least privileged security design. You can check containers for vulnerabilities. Both Cloud Run and GKE will scan your containers and surface those vulnerabilities in context of those products. You can enforce a central binary authorization policy to decide if container images should or shouldn't be deployed to either Cloud Run or GKE, depending on things like have they been scanned, who has tested that image. And finally, you can put all that within the same VPC service control perimeter. When it comes to networking, with a global or a regional application load balancer, you can serve some endpoints on Cloud Run and some endpoints on GKE. From your user's perspective, they're calling the same domain. It's the same thing, except that some requests will go to Cloud Run, some will go to GKE. And actually, that's how you can move between Cloud Run and GKE invisibly from your end users. You can, from one day, start shifting traffic from GKE to Cloud Run, from Cloud Run to GKE, even gradually, thanks to application load balancers. As I mentioned, you can directly connect Cloud Run services in your cluster's VPC. And you can even give private IPs to Cloud Run services by using an internal load balancer. So that's how you can use Cloud Run and GKE together. But now a question that you might have is, for a given workload, for a given service, what runtime should I pick? And what we like to say is, if a workload is a fit for Cloud Run, which means that it is an autoscaled service or a batch job, we like to recommend starting with Cloud Run. And if it's not a fit, pick GKE. As I mentioned, you can always go back and forth easily later if you need to. So we like to think that Cloud Run is the best way to get going with containers, and that we've enabled using Cloud Run and GKE together. That wraps up our talk. Thank you very much. We will be taking some live questions if you want to at the mic right here, or you can catch up at the end. We'll be around.
And
Thank you.
Please use their